27 want us to find functions f and g so that f of g equals this function h. So remember, the simplest way to do it is to replace all this with the x to be your first expression, so absolute value of x, and then everything inside will be your second equation, so 6x plus 6 would be g of x. That always works. It doesn't say anything about multiple, because f of g means you would take this and plug it in for x and you would get that. So a is the one that would match. That would always be the simplest way to do it. Alright, so this one says use the graph, find the intervals on which it is increasing, decreasing, or constant. Okay, so does it say which order we're going in? Okay, so look at this graph. It is increasing, going up from left to right when x is negative pi over 2 until we get to the x value of pi over 2. So increasing from negative pi over 2 to pi over 2. That's the only part. So A does not match. B, I'm just looking for the increasing part. Don't see it. C, increasing on negative pi over 2 to 2. So that one will be good. I didn't even do the decreasing, so decreasing from negative pi to 0. Oh, sorry, x values, negative pi to negative pi over 2. And then also decreasing from pi over 2 to pi. And that's the only one that matches with the increasing, so everything else falls in line. Number 29, we want to solve this equation. So the trick here would be to write all of these as, I think we could just write them all as base of 3. Okay. That would probably be the easiest thing to do with the exponential form. So we have 9 to the 2x times 27 to the 3 minus x power equals 1 over 9. Alright, so this can be rewritten as, the 9 can be rewritten as 3 squared, and that's still raised to the 2x power. 27 can be rewritten as 3 cubed, and that's still raised to the 3 minus x power. And then we can write this as 1 over 3 squared. We're going to move this up, and we're going to multiply these powers. Power to a power you multiply. So this will give me 3 to the 4x, and then this would be times 3 we have to distribute. So this would give me 9 minus 3x, so 3, 9 minus 3x, and this will be equal to 3 to the negative second power. Now, property of the exponent says when you multiply with the same base, you add the exponent. So I would add the 4x to the negative 3x, and this will give me 3 to the 9 plus x, and that equals 3 to the negative second. Same base, one on each side. We can just focus on the 9 plus x equals negative 2. You subtract 9, you get x equals negative 11. That's all we can do with that one. So answer choice D. Alright, this one wants us to determine algebraically whether the function is even, odd, or neither. So even, odd, or neither refers to the type of symmetry it has. I want to just go back and show you guys the graph. Let me pull the full screen up. Let me go to videos, and in chapter 2, and the parent function. I don't know if x squared is one of those graphs. 1 over x squared. I don't believe it is. We got 1 over x. I don't know if 1 over x squared is one. It'd be nice if we could see the graph. Okay, don't see it on the graph. So let me go back and show you how to actually evaluate it. So the way you determine even, odd, or neither, you do f of x, and you set it equal to f of negative x. So if you remember, negative x flips across the y-axis. This refers to as even. So if these two expressions are the same, then the function is even. So what I would do is compare the original 1 over x squared to that of 1 over negative x squared. When you square a negative, it becomes positive. So that gives us 1 over x squared. So this is the same as this, so it is even. Now, there is x-axis, which they don't ask for, but you would compare the original, f of x to a negative on the outside f of x, and see if those were the same. And if we just added a negative on the outside, they wouldn't be. So it would be 1 over x squared, and if that's equal to negative 1 over x squared, negative on the outside. They're not. So this would just be x-axis. When you change the y, it'll flip across the x-axis. So it does not have x-axis symmetry. And then the third one is odd. So that is f of negative x. You compare that to negative f of x. Now we've already done both these parts. F of negative x came out to be that. The negative on the outside came out to be that. Those two are not the same, so it's not odd. So it does have even symmetry, but that's it. So this is even.